Hello, hello, welcome back. This is part 3. Okay, so we covered double zeros in the last video. And so here we're going to go ahead and put everything we learned in the first video and the second video and put it together in this third video and take a look at how do we put those together and graph. Okay. But before we actually start, let's just kind of recall maximums and minimums. Okay, so suppose that you have a graph that looks like this. Okay, so if you have a graph that looks like this, okay, so down here, this is a minimum, and over here, this is a minimum, and up here, this is a max, and this is a max, right? Okay, so we call these local extrema. Okay, so local extrema. These are your max and mins. Okay, and it turns out that if your polynomial is, I'm going to write it like the fancy way with a bunch of A's. Well, we know they're in there. Okay, so plus A naught. Okay, is a polynomial. So if P of x is a polynomial of degree n, then the graph of P has at most n minus 1, so 1 less than the degree. So if the degree is 5, then n minus 1 would be 4. Okay. Has at most n minus 1 local extrema. Okay. And that's kind of a big deal. Okay, so if it's degree, so here, let's see, 1, 2, 3, 4. So in this particular graph, there are 4, 1, 2, 3, 4 relative extrema. Okay, so this this definitely cannot be a degree 2 or a degree 3, right? Or a degree 4, because here it will have, oh, I forgot the T. Okay, it has at most n minus 1. So if it's degree 2, right? If it's degree 2, then it'll have 1 extrema. If local extrema. Okay, if it's degree 3, then it will have at most 2. Okay, if it's degree 4, then it will have at most 3. Okay, this one has 4. So we know that this polynomial here is not a degree 2 polynomial. It's not a degree 3 polynomial. It's not a degree 4 polynomial. However, degree 5 would have 4. So 1, 2, 3, 4. So this could be a degree 5 polynomial. Okay. All right. Let's take a look. All right. So for example, if I have this polynomial P of x, which equals x to the 4th plus x cubed minus 16x squared minus 4x plus 48. So if I have this, I see that this is a degree 4. And so that tells me that there can be at most 4 minus 1, which is 3, local extrema. So I can only have 3. Okay. if I have this, p of x equals x to the 7th, no, sorry, 7x cubed, 7x cubed plus 2x squared minus x plus 5. If I have this here, so the degree is 3 here. So then you can have at most 3 minus 1, which is 2 local extrema. Okay, so just kind of keep that in the back of your mind as you're graphing, so that when you do your graph, you can always double check to see if, okay, I have 1, 2, I have 1, 2, 3, 4 relative extrema, but it's a degree 3, so that's got to be wrong. Okay, so you can always use this idea here to kind of check your graph as you go. Okay. All right. So let's take a look at graphing. And this makes sense, right? Okay. Because if it's degree 2, right? We said it would have 1. Isn't degree 2 like x squared plus 3x minus 1, something like that, right? And so that would be a parabola, right? It has 1 extrema right there, a minimum. Okay. So it makes sense. Okay. All right. Graphing. Okay, so when we're graphing, we're going to go ahead and find the end behavior. And we're going to find the real zeros. Okay, and then we're going to sketch the graph. Okay, all right, so let's take a look at this example here. I guess, you know what, let's add this. I don't normally do this, but I think I get the feeling that WebAssign will ask you to do this. Let's say find. Let's just be consistent. Find a few extra points. All right, so let's go ahead and sketch the graph of p of x, which equals x plus 2. Let's start off with one that's already factored. X minus 1, x minus 3. Okay? All right, so let's get the leading term. So if you remember here, the leading term, I just need to multiply this leading term with this leading term with this leading term. So that's going to be x times x times x, which is x cubed. All right, so let's do the left-hand behavior. All right, so left-hand side, x is negative, so I'm going to plug in negative infinity to the third power. And negative to the third power is negative, so we get a negative result. Right? All right, so on the left-hand side, it will be falling as x goes towards the left, which is negative. Our graph, our y values, will go down. All right, the right-hand side, x goes towards positive infinity, so I will plug in positive infinity. Positive to the third power is positive, and then we just get infinity to the third power, which is very positive. Okay, so as x goes towards the right, our y values go up. Okay. All right, so far, what do I know? I know on the left side, it will be going down, and on the right side, it will be going up. All right, let's get our real zeros. All right, so we have to plug in 0 for y. It's already factored. So x plus 2 equals 0, x minus 1 equals 0, or x minus 3 equals 0. Subtract 2, x equals negative 2. Add 1, x equals positive 1. Add 3, x equals to 3. All right, so a point at negative 2, a point at 1, and a point at 3. Okay? All right, so we need just a few extra points so that we kind of know how it behaves in between these points. Okay, so let's see. Let's get the y-intercept. Let's choose x equals 0. Okay, so when x is 0, let's plug 0 in for x. Here, extra points. All right. I'm going to choose 0. What else will I'll choose negative 1. Negative 1's a good one. And 2 looks good. All right, so I'll choose negative 1, I'll choose 0, and I'll choose 2. Okay, so when x is 0, we get 2 times negative 1 times negative 3. 2 times negative 1 times negative 3. That becomes 6. Okay, so we have a point at 0, 6. 0, 1, 2, 3, 4, 5, 6. Okay, negative 1, we get 2 minus 1 is 1. Negative 1 is negative 2. Negative 1 minus 3 is negative 4. So we get 8. Kind of out of room. We'll pretend that's 8. All right, and when x is 2, we get 4. 2 minus 1 is 1. And 2 minus 3. All I'm doing, if you're wondering, what am I doing here? All I'm doing is taking these x values and plugging them in here. So like with the negative 1, plugged in negative 1. Negative 1 plus 2 is 1. Negative 1 minus 1 is negative 2. Negative 1 minus 3 is negative 4. And then I multiplied them and got 8. And now I'm doing the same thing with 2. I plug in 2 over here. 2 plus 2 is 4. That's how I got this. 2 minus 1 is 1. And then 2 minus 3 is negative 1. Okay, so we get negative 4. All right, so 2, negative 4. 1, 2, 3, 4. All right, so we have a general idea of what's happening here with our graph. So we see that it does something like this. It may not be exact, but it's pretty close. So you want to look for these very specific points that I have here when you're doing your homework. And if you're doing some sort of, oh, which of the following graphs go with this polynomial? Okay. All right. So again, get your left-hand behavior because that'll help us figure out how to guide our graph. Left-hand behavior is down, and we see that it is. Right-hand behavior is up, and we see that it is. Okay, and we have all of the zeros, and then we got a few extra points. Okay, all right, let's try another one. All right, let's go ahead and sketch the graph of p of x, which equals x cubed minus 2x squared minus 3x. All right, let's use this leading term. And we'll use this leading term to get our left hand and right hand behavior. All right, left hand behavior. X goes towards the negatives, so I will plug in negative infinity. And negative to the third power is negative. And so we get a negative result. So on the left-hand side, the graph is falling. Okay, so as x goes towards negative infinity, our graph, y, goes towards negatives. Okay, the right-hand side. All right, so right-hand side, x goes towards positive infinity. So I'm going to plug in positive infinity. And positive to the third power is still positive. And then we get infinity to the third. So we get positive on the right. All right, so as x goes towards the positives, y goes towards the positives. Okay. All right, so far, this is what I know. Left-hand side will be falling. Right-hand side will be going up. All right, let's get our real zeros. So 0 equals x cubed minus 2x squared minus 3x. They all have x in common. X squared minus 2x minus 3. And I will factor this. X times x, positive, negative. Looks like 3 here and 1 there to give me negative 2 for the middle. And so x equals 0. X plus 1 equals 0. X minus 3 equals 0. This one is already solved. Minus 1. Add 3. All right, so we have a 0 at 0. Negative 1. 1, 2, 3. And 3. Okay? All right, so let's get some extra points. All right, extra points. Let's use, I like these two for sure. So let's use x equals 1 and 2. And we really should get something in between here. So negative 1/2. Use your calculator. All right. Okay, since I have the factors over here, I'm just going to plug in here. So x equals 1. So when I plug in there, I get 1. When I plug in 1 over here, I get 2. 1 plus 1 is 2. And when I plug in 1 over here, 1 minus 3 is negative 2. All right, so that gives me negative 4. Okay, so 1, negative 4. 1, 2, 3, 4. 2. All right, so plugging in 2 into here, so I get 2 there. I get 2 plus 1 is 3 for the middle. And over here, 2 minus 3 is negative 1. All right, so I get negative 6. 2, negative 6. All right, and then negative 1/2. That will give me negative 1/2 times 1/2 times, what is that there? That's going to be negative 7/2. So this is going to give me 7/8. All right, so barely 1. Okay. All right, but that gives me, if you kind of zero in on this graph here, that gives me a pretty good idea of what's happening. So it looks like we have something that looks like this. And my end behavior matches. Left-hand side goes towards negatives, right-hand side goes towards the positives, and I go through all of my zeros and my few extra points. Okay? Whether or not this is an actual maximum is debatable. Normally, if I give a paper pencil test, I just ask for a rough sketch. You could be here all day trying to figure out where exactly that maximum and minimum values are, and you use calculus to figure those values out. Okay, so that's how you do these graphs. And notice that all of the zeros here have multiplicity 1. We don't have any double zeros. Okay, so this next video, that's the end of this one. So the next video, we'll continue with the graphing, but we'll look at some examples where you do have a double zero. Okay, all right, so stay tuned.